extended access lists are numbered from 100 to 199. Filter, permit or deny by protocol, source address, destination address, or port number. They are placed as close to the source of traffic as possible. They work at layer 3 and layer 4 of the OSI model. We wish to block host 1 from accessing the web page on the www server located on the LAN on F01 of router 2. Writing an extended access control list. This is the syntax for writing an extended access control list, much longer than a standard access list. Access list number 100 through 199. This will be your ACL number. Your permit or deny statement. The protocol. This is the protocol to be permitted or denied. It can be IP, TCP, UDP, ICMP. The source address. This is the source of traffic. It can be the individual host address, the word host, or even the entire network. The wildcard mask. This is the wildcard mask for the source. It can be for the entire network, a quad 0 meaning must match all octets, or the individual host address if the word host was used for the source address. The destination address. This is the destination of traffic. It can be the individual host address, the word host, a portion of the network, or the entire network. Wildcard mask for the destination. It can be the mask for the entire network, the quad 0 meaning must match all octets, or the individual host address if the word host is used for the destination address. The logical operation such as equal, EQ, not equal, NEQ, greater than, GT, and less than, LT. And then the port number. The port number could be a number or a word such as 80 or www, 23 or telnet. You would use the word if you forgot the port number. 3 examples. Access list 100. Deny TCP 148.10.10.0 with a wildcard of 0.0.0.7, 150.50.5.3, quad 0, EQ 80, or I could have went EQ www. This would deny the entire network of 8 addresses. Access list 100. Deny TCP 148.10.10.3 with a quad 0, 150.50.5.3 with a quad 0, EQ 80. This will deny only the specified host address. Access list 100. Deny TCP host 148.10.10.3, host 150.50.5.3, EQ 80. This will once again deny only the specified host address. The statement must be followed by a permit any to allow all remaining traffic. Otherwise, the implicit deny any will block all IP traffic, thus turning your router into a big black hole of the internet. Access list, whatever number, permit IP any. We write the ACL in router 0 and will apply it to the fast Ethernet 00 interface inbound. You follow the projected path of the packets. They would attempt to start at host 1, enter router 0 through fast Ethernet 00, leave router 0 through 000, enter router 1, exit router 1, enter router 2, and attempt to exit out fast Ethernet 01. We are going to block it at the fast Ethernet 0 interface of router 0. Building the ACL and applying it to the appropriate interface. In router 0, the global config prompt, access-list 100, deny TCP host 148.10.10.3, host 150.50.5.3, EQ 80. Access-list 100, permit IP any. These commands build the ACL. Interface fast Ethernet 00, type IP access-group 100 in. This command applies the ACL to the interface in the proper direction. This will block only HTTP traffic from the host to the destination, but still allow ping, telnet, FTP, and other protocols to the destination. For this demo, we'll build an access control list to deny access to the World Wide Web server, the web page, for the PC over here, PC number 5, which is in the upper portion of the VLAN 58 network, 148.10.10.0 with a /29 network. That's a range of 8 addresses. So we'll be blocking the upper 4 addresses. First of all, we check to make sure we have connectivity to the website. Open up our PC, click on the web browser, and at the URL we type in the address of that server, 178.10.10.2. Hit enter. The web page comes up. We'll click on the little image here and see what it's got on the web page image. There we go. We have connectivity from PC 0. Now we're going to check PC number 5, make sure we have connectivity before we go anywhere. And the same thing. Close that down. We're going to go into our router, build our ACL, because an extended access list blocks traffic closest to the source. So we're going to go into our router, terminal prompt, press enter. Go into the global config mode. We type in access list. So access list 101. Remember, because 100 through 199 are extended access lists. And we want to deny, I have to put a space in there, deny TCP is the protocol. And we're going to go 148.10.10.4 because our address range is from the .0 through the .7. So you kind of 0, 1, 2, 3, and we're starting from 4 and going up that we're blocking. And this is where we take a portion of the wildcard mask for letting us know that we're only taking the upper portion of the network. So we go 0.0.0.3. And then we're going to block it. This is the destination we're blocking to, the actual host, a single entity over there, and the address of that server, 178.10.10.2. And we're going to put our equality statement in there, and either 80 or www. I'm using 80. Now we got to complete it by permitting anything else in there. Access list 101, permit IP any. This is any host to any network. IP is all remaining traffic, ping, telnet, everything else. All we're doing is we're denying World Wide Web access to the upper portion of that 148.10.10.0 network. Now we have to go into the interface and apply it. But because this is a VLAN, it is on a sub interface. So we must interface the sub interface of Fast Ethernet 0/0.58 because that's the VLAN. And now we go IP access -group 101, and the packets are coming inbound. Once this is applied, this access list is in effect. Right now it's just built. It is not in effect, but when I hit the enter key here, this access list is being built. So we're going to minimize this one. We're going to go over here and make sure that we can still get access from our PC that should get access. And we get it. We go down to the PC that should be denied access now. 178.10.10.2, and it should come up say request timeout. And it did. So this shows us that our access control list is working. If we go to any other PC, we'll make sure that any other network can still get there. So we're going to go to this one here, desktop, web page, and we type in the address of 178.10.10.2, and we can get there. This concludes this exercise.